This lesson is on properties of real numbers, section 1-2. These properties work for addition and multiplication. So commutative property is all about two things switching spots. So it works for addition and multiplication. For example, you could take the numbers 5 plus 1 and switch them around on the other side, 1 plus 5, and each side is equal to 6. So if I have variables in there, a plus b, that's the same as b plus a. They're going to be the same thing. And it also works with multiplication. Say I'm multiplying two numbers like 3 times 6, and that's the same as saying 6 times 3, which is both sides equals 18. If I put two variables there, it's like BC is the same as C times B. So just switching things around. So think about commuting back and forth to school. It just flip-flops the direction. You follow the same route, but switches it around. Associative is all about grouping things together. So the key thing here is to look for some parentheses. So I could group three things, like 1 plus 2 plus 3. I'm going to keep the order on the other side. The only difference is I could add 1 and 2 first and get 3, then add 3 and get 6. Or on the other side, you could add 2 and 3 first and get 5, and then add 1, and you still get 6. So you just add the first two or add the last two. But look for those parentheses. Likewise with multiplication, if we multiply three things together, I could say 1 times 2 times 3. Oh, sorry. Hold on. So I could do 1 times 2 times 3, and that's the same as 1 times 2, and then multiply it by 3. So the left side gets 1 times 6, which is 6. On the right side, 2 times 3, which is 6. So look for parentheses or a grouping for associative property. Identity, think of taking a selfie. All right, if you take a selfie with a camera, you're going to get yourself back. So what is the additive identity? So let's think about this. 5 plus some number is going to give me 5 back. So if you add 0 to anything, you get itself back. So that's 0 is the additive identity. Likewise for multiplication, if you have 7 times some number gets 7 back. So 7 times 1 is 7. So 0 is the additive identity, 1 is the multiplicative identity. And you could do this with variables as well. Say you had, instead of 7, b times 1 equals b, or a plus 0 is going to be a. The inverse, so if I'm talking about addition, if I add two numbers, how do you get the identity of 0? So think about it. If you had 7, what do you need to add to 7 to make 0? Well, it's opposite, negative 7. So think opposites for additive inverse. But from our multiplication, if you multiply two things, how do you make the identity of 1? So if I take, let's say 14 times the reciprocal, 1/14 equals 1. So this one's about reciprocals. So just be careful when you're working with addition versus multiplication. And like I said, you could replace these with variables. I just gave you concrete examples. The distributive property, some examples of that would be like a times b plus c. And that's, I draw these little arrows, kind of like a rainbow. That means a times b plus a times c. And we'll get into some more examples here later. So those are all the properties. The Google form is going to ask you some questions about matching the property name. This question is a real-life application of the distributive property. So you have components of a computer that are offered by Computer Depot, shown in the table. You have 6% sales tax that is added to the purchase price. How much sales tax is charged for the computer? So you need to figure out how much sales tax. So from the chart, I want you guys to try this one on your own. Come up with 2 different ways of just getting the sales tax. And we'll talk about that one later. So here's applying the distributive property. So I'll go through a few examples here. I always like to draw these little arrows so I remember to go to both things, or every number or term inside the parentheses. So 3 times 2q is 6q. 3 times r is 3r, and there's plus in the center. And then we have an addition. 5 times 4q is 20q. And then we got minus 5 times 7r is 35r. And then you have to combine like terms. And I like to box them, underline them, color code them. But like terms have the same variables. So 6q plus 20q, that's 26q. And then if you take the r's, you have 3r. And then here, be careful, include the sign that comes before it. So 3 minus 35, those coefficients make a negative 32r. And you can't combine the q and the r's, so that is your final answer there. The one below it, same idea. We're going to distribute the 3 to both terms here. So 3 times 4 is 12x. 3 times 2y is 6y. On this part, be careful, you're distributing a negative 2, not a positive 2. So negative 2 times 3x is a subtracting of 3x. Negative 2 times the y is minus 2y. And then combine like terms. So we got 12x minus 6x is positive 6x's. And then the y's, we got a negative 6y minus a 2y, which is negative 8y, or minus 8y. So 6x minus 8y is that answer. And lastly, here are the 2 you-try questions. You can split this workspace and put number 14 here, number 16 here, and then you can write your answers up in the boxes. The Google form is going to ask you to input the answer to number 16, so I can kind of see how well you guys understand this before we discuss it the next day.